Okay, so this lab is about how to bend liquids. So first up, we're gonna need to know the difference between polar and nonpolar. I don't know what the video did. Okay, so polar is when a molecule has a positive and a negative side, but nonpolar is they share the electrons equally between the atoms. So right here, here's a balloon, and here is a lady with a bunch of hair. And to do this lab, you're going to have to rub your hair against the balloon, and that's going to get a bunch of electrons into that balloon, and it's going to create a net negative charge in the balloon because of all these electrons and the static. So here is Lewis structure of H2O. Two hydrogens and an oxygen, lone pairs on the oxygen create negative sides, hydrogens are positive. This is the negative and positive, obviously makes the water polar. So here is that balloon from earlier that is filled with all of those electrons. And here is a bottle of water. And it's going to come out of the bottle of water, just like the lab's going to do. And you're going to have, some negatives and positive sides to these things coming out. And these positive ends of those hydrogens are going to be attracted to the negative ends, to the negative field of the balloon. So here it is again, the balloon. The water, as you can see, is kind of tilting towards that negative field of the balloon. This is because water is a polar molecule. When the water senses the net negative charge of the balloon, the positive H pluses are attracted towards the balloon, bending the stream of H2O. So just like in the Lewis structure, we had the negative side of the oxygen and the positive side of the hydrogen. That positive side of that water coming out of the bottle is just going to bend towards the negative side of the balloon. But what can we conclude from this? Well, that polar molecules will be attracted to the negative field of the charged balloon, or just in general, that because polar molecules have one pole that's a negative and one pole that's a positive, they'll be attracted to anything that has a net charge because rather than a neutral charge. But what about nonpolar molecules? Because we haven't really talked about those. Well, just a reminder from what we did talk about is that it's equal sharing of electrons between the atoms. So let's just give an example of just a molecule that's nonpolar. And that would be methane, CH4. So we have carbon in the middle, 4 hydrogens surrounding it, and then little single bonds connecting it to the carbon. There are no negative or positive ends to this compound. You can clearly see that. There are no excess lone pairs or anything like that. So it isn't polar. It's a nonpolar molecule. And you can see that in the structure, Lewis dot structure. So here is that balloon again with all of those electrons inside of it that we got from the static from rubbing it against like your jeans or your hair. And here's a nonpolar liquid, which is different from the H2O from earlier because it was polar. And as you can see, this stream is straight and it doesn't curve. Why doesn't this bend when the nonpolar liquid comes out? Well, the balloon will always and forever have that net negative charge inside of it. But the big difference here is that the liquid does not have the positive end for the negative balloon to attract because it just has a neutral charge to it. So there's nothing for the balloon to attract, and there's nothing that the molecule itself wants to go towards. We will test the following liquids to find out which are polar liquids and which are nonpolar liquids. So we will test water, hydrogen peroxide, salt water, and olive oil. Here are the pre-lab questions. They will help the students focus on the concept to be explored and give a better understanding to those wondering what's happening in the lab with each of the molecules and liquids. So to get started with this lab, you will need the following materials for 2 entire classes. $7.99 worth of balloons on Amazon. You will need $12.32 worth of food coloring, also on Amazon. You will also need $6 on Amazon for your foam bowls. You will also need salt, which is $1.69, also on Amazon. You will need a lot of water, but that's free because of running tap water. You will also need hydrogen peroxide, which is $2.58 on Amazon. Lastly, you need olive oil for $16.99, also on Amazon. Your total doing this lab for 2 classes will be $47.57. So you're going to want to fill up each of your containers with the previously mentioned 4 liquids, and then you're going to take the top, take your sharp thing and stab a hole in the top like I did. Yep, just stab a hole in the top so that the liquid can like stream out. So here's your liquids again: water, hydrogen peroxide, olive oil, and sea salt. Sorry, salt water, but you're going to add, to make the salt water, just add sea salt into regular water and then just make sure you mix it up and it dissolves and you're good. Next up, some of the cautions right before you start your lab: do not consume the hydrogen peroxide or just any of the liquids. And don't get it in your eyes, don't rub your eyes. Maybe you should wear gloves to be extra safe. But do not get it in your eyes. It will burn. And yeah, like I said, be wary of all the liquids, just, especially with the food coloring in there. Also, this little stabby thing that you're going to use to stab the top so that the stream of water can come out is very sharp. So don't poke yourself with that sharp edge or whatever you're using. So yeah, be careful. Also, if you spill, like I did right then, oh no, you have spilled, and you're just gonna need to grab a towel, and you need to have these bad boys at the ready. Yes, just make sure to keep plenty of towels for spills. Okay, so grab your bowl out to begin the lab, and then you're going to rub that balloon against your hair to get all those electrons into the balloon. First up is water. So you can see that that little tiny stream of water is kind of going towards the balloon. Next up is salt water. Again, you can see that that little blue is going towards the balloon. It's attracted to those negative forces. Next up, hydrogen peroxide. I think this one's like the most obvious of them all, but you can definitely see it bending towards the negative balloon. And then here's olive oil. Look how boring he is. He's not bending towards the balloon. So what can we conclude from this? Well, first it would be beneficial to fill out this table with the 4 compounds: water, salt water, hydrogen peroxide, and olive oil, and then you can determine the Lewis structure and also the observations from the lab which you have completed. In reference to the expectations, the outcome you should expect is that 3 of these will be polar and bend when they come near the balloon, and 1 is nonpolar and will continue a straight line as shown before in the demonstrated lab. These, lastly, are the post-lab questions that you need to answer that will kind of finalize everything that's happened in the lab and your comprehension of them. Lastly, these are the multiple choice pre-lab questions and the free response questions. It's the key for it. But anyways, that's it.